Yeah, I think Anil is going to start and then I'll...
Yeah. Hello everyone, my name is Anil. Maria and I would like to present the design for integrating my identity mixer with Fabric CA and today's session. So if you have any questions, please feel free to interrupt anytime. As you all know, how do I move to the next slide? Sorry, yeah. So basically in this session we'll talk about how integrating the identity mixer with Fabric CA. Today Fabric CA can issue X509 certificates, as you all know. The goal is to enhance Fabric CA to issue both X509 certificates as well as Idemix credentials. This is a step towards fully integrating identity mixer with Fabric. I think there has been some effort to integrate identity mixer with MSP, so this is another step towards fully integrating identity mixer with the Fabric. So there are some goals we are trying to solve with this design. One is, the first one is to allow the users to get identity mixer's Fabric CA's public key, as well as Revocation Authority's public key. I think Revocation Authority is something that Maria is going to talk about in the next few slides. And the next one is ability to get identity mixer credential from CA with a set of attributes, and also to ability to get revocation information from CA. And to revoke identity mixer credentials of a user. And you can find the design document and the specified link there. I would really appreciate if everyone can take a look at it and let us know your comments. So Maria, I'll pass it over to you to talk about identity mixer.
Thanks, Anil. So. Hi everyone. Yes. So now I would like to recall a little bit identity mixer and a bigger picture and the status, and then hand over back to Anil for implementation details, and then I'm gonna also come back in the end and talk about details of revocation, because actually issuing credentials with Fabric CA is very similar to X509 case. So the only different part is handling revocation. So that's why we're going to talk about it in more detail. First things first. So you know probably everyone that what Identity Mixer is. It's attribute-based credentials. It's very similar to X509 certificates. So you get a set of attributes certified by CA, and then later. So the main difference between X509 and Idemix is that you don't attach the certificate when you sign something with the corresponding key, but rather you generate a zero-knowledge proof of possession of certificate, and that allows you to reveal selectively things about from your certificate, and also it allows to make both different transaction signings completely unlinkable. So also Identity Mixer technology includes different features like privacy preserving revocation, because since we talk about unlinkably showing your credential, we cannot use certificate serial number for revocation anymore. So we will talk about it later. So and if Anil, you go to the next slide. So basically, that's a kind of a comparison between Identity Mixer within versus multiple X509 certificates. So, or just in general X509 certificates. So actually, issuing certificate is very similar. It's a set of attributes certified by the CA. But then later with X509, you to have the unlinkable transaction signing functionality, you would need to use fresh X509 certificates every time. That was the effort with T-certs before the transaction certificates, but that was kind of cumbersome and had an overhead. So the Identity Mixer technology is something that is kind of tailored for that use case. So basically, you get only one Idemix credential, which is your enrollment certificate, certifies your attributes. And then using this single certificate, you can unlinkably sign transactions and generating this transaction certificate, so-called, or rather zero-knowledge proof, possession of this enrollment certificate on the fly without interaction with the certificate authority. And you can also have selectively disclosure of attributes. You can have auditability inspection. That's a feature that we're not going to kind of cover today, but that would also come. Basically, the trust model is exactly the same as in X509. So the verifier needs to have the public key of the CA to be able to verify that zero-knowledge proof. So in this case, the trust setup and kind of key distribution is the same as for X509. So if you go to the next slide. So basically, there was, this is an overview of the effort to integrate Idemix in the Fabric. So we have two libraries right now in Go that is used by MSP and will be used by Fabric CA, or is being used already actually, because we have already some implementation. Anil has already implemented a few things. And we have also Idemix library in Java. This is used by client SDK in Java. So the Java part is under review now. The MSP is mostly merged. That was released as experimental feature in 1.1, except the revocation functionality. So that's what we will add to the Idemix library in Go, the revocation part. And then we will update the MSP for to support revocation. Basically verification of the non-revocation proof. And the Fabric CA is what we're going to talk today. We'll also be using the same Idemix library in Go. And there is also one kind of question that Angela and I wanted to bring up at the end of this call, is we're thinking of, there is a typo here, so to refactor Idemix to support basically BCCSP interface. So, and that wanted to discuss if it's better to do that kind of commit now or postpone it for later. That would also enable easy integration with the HSM. So this would come back later for discussion. So if you go to the next slide, Anil. So for revocation, because we're going to kind of talk about it and use also, Anil is going to use in the implementation details a few terminology that is a little bit different from X509 terminology. I wanted to introduce kind of the big picture here for revocation. The certificates, when they are revoked by so-called the revocation handle. This is similar to serial number of the certificate in X509. The revocation handle is embedded as an attribute in the certificate, and this is unique per certificate. The CA stores this attribute. So when the certificate is revoked, then it's revoked by this revocation handle. So, and the main difference on a very high level between the X509 and privacy-preserving revocation here is that we cannot reveal this revocation handle in the clear during the transaction. So it cannot be just checked against the blacklist, because then the transaction will be linkable because it's a unique number. So instead, what the high-level idea for all privacy-preserving revocation methods is that the user creates a zero-knowledge proof that the revocation handle that is signed inside the certificate was not revoked with respect to the revocation information that is available. So the revocation information you can think about as a CRL, but it doesn't just have the revoked revocation handles in the clear, but it also has some cryptographic information that would allow the verifier to verify the zero-knowledge proof without knowing the exact value of that revocation handle. And to handle all the revocation that we introduce the revocation authority, it doesn't need to be a separate party. For now, we just say this is a component, like API that we provide that is called by the CA, but it can be also a single revocation authority for multiple CAs that handles that more global revocation, or it can be one component per CA. So this doesn't matter. So you can think about it as just API that does the functionality, and that's what we add to the Idemix package basically, and the whole corresponding crypto operations. Yeah, so that's it, and I guess the next slide, if you and your goal is just highlighting that revocation handle is like serial number, the revocation information. You can think about CRL. We don't call it a CRL because it's not just a list, and it can be also white list that we'll talk about later, or more complicated. Or even more simple objects. So that's why we call it just revocation information. And the revocation authority component is just introduced. So I guess now, Anil, if you go to the next slide, this is now your part, the details. So then I hand over to Anil now, unless there are any questions so far.
Okay, so if no questions, I'll just continue with the next slide. So first thing that would need to happen for a user to generate a credential is to get the CA's public key and revocation authority's public key. So when the CA starts up initially, the public key and the secret key are generated, and same for revocation authority. So this is the one-time thing that gets generated and stored on the disk. And the users can then ask the CA for the public key of CA and revocation authority, and they can use that information. They can store it in their wallet or on the disk, and then use that information to generate the credential. So today we have API v1 CA info endpoint in Fabric CA that allows the users to get CA certificate chain. So the idea here is to, basically what we are looking at is to enhance this endpoint to not only return the CA certificate chain, but also the CA and RA's public key along. So that's the enhancement that we do for that. And then along with it, we will also enhance the get CA cert command to handle the public keys and store it on the disk. So once a user has the public key of the CA, now the user can go ahead and generate a request to get a certificate, to get a credential from the CA. So the issuance is a two-step process. First, the user would have to get a nonce from the CA, and then using the nonce, he would create a credential request. So you can think of credential request as a zero-knowledge proof of the user's secret key, and then the CA gets the request from the user, gets the revocation handle from the revocation authority, and also the CRL, the revocation information, and generates the credential and sends the credential and the CRI, which is the revocation information, back to the user. So that's the flow. So we will be adding.
Why do we need to make two calls? Can you go back?
Oh yeah. So this is the nonce. So Maria, you want to talk about nonce? Why it needs to be a two-step process?
Yeah, this is like basically a requirement for to prove the cryptographic scheme secure, to prove the overall system secure. So this is kind of a requirement that we have that is not some functional requirement, but more like a requirement from the security proof to prove the overall system secure, so that the overall system is provably secure. Basically, we need to have a nonce, and we need to have this credential request to be kind of fresh and unique. That's why we require nonce for identity mixer issuance. So and it has to come from the CA. So that's the only difference.
You're tracking the not uniqueness of nonces and matching on the CA. I got it. Okay, that makes sense.
Is the role
in the Idemix MSP, the revocation authority needs to be integrated in the MSP, right? Because you need to know at validation time if the client is not revoked.
Yes, so we're going to talk about it later. So we change, so the revocation authority is kind of handles the whole process of generating this revocation information and handling revocation handles, but the MSP will be enhanced with the means to verify the non-revocation proof, as well as the client SDK part. So the client SDK part, well, Idemix library would, when generating a transaction signature, will also include the proof for a non-revocation proof, and then the MSP will be enhanced to be able to verify that proof. And the only input the verifier would need is the revocation kind of parameters, basically the public key of the revocation authority and the CRI. The CRI can be different format. I will explain the details later. It depends on the mechanism we use. It can be just one public key or the epoch description, or it can be a longer kind of list of cryptographic values. So this will enhance and will be kind of transparent to the API. So it's just if the proof will be done automatically when the user signs the transaction, and verification is done as a part of verifying the zero knowledge proof. It's just the certificate, the CRI or revocation authority public key would need to be passed as well, together with the CA public key, as an input for verification.
So at the end of this process, what will user possess? What will user have after Idemix credential certificate?
So user would have the credential, the secret key, which will be stored in one file called sign and config, and then the revocation information, which is the CRI.
And attributes.
And that will be in addition to the public and private key and the cert it gets from certificate authority, or will that be not the case?
So the user stores public key of the certificate authority, public key and of the revocation authority, the current version of the CRI. It can also fetch the next versions later before doing the proof. And it has the Idemix credential, which contains of the secret key of the user, the attributes, list of attribute values of the user, and the signature from the certificate authority. And this is enough to basically to do the proof and to sign transactions. But we will actually, there is a slide on the token generation later, so we can also talk about it in more detail.
Is the Enroll API the same API for X509, or is it a new API? And I have another question. Is the anon just a transient thing then? It doesn't sound like you have to save it.
So this is going to be a new API. It's going to be introducing a new endpoint for that. And the same endpoint would be used for getting the nonce as well as getting the credentials. Right? So. And the nonce
is just a transient thing.
Yeah, nonce is a transient thing. So nonce, the initial call would be to this same endpoint without the credential request. So the server would respond back with a nonce, and using the nonce, the user would create a credential request and send the credential request to the same endpoint, which will respond back with a credential, a new credential for the user. So the user would use the same access control mechanism. So it can accept both basic authentication, which would be the user ID password that the user would have got through the registration mechanism we have today, or using a token authentication. If a user already has a X509 certificate, the user would be able to use that certificate to create a token, like they would do today, today's implementation, to make the request.
Or even if the user has an Idemix credential, and if this is a request for reissuance of the enrollment certificate, we specify the format of the authentication token as well for using Idemix credential.
Yes.
Can I ask another question, please?
Sure.
Nope.
So if in the peer, in the MSP, we know the way we know if a user is revoked is by knowing the complementary. If the user is not revoked, and each time a user is created, registered in the CA, in order to know that it is not revoked, we need to update the MSP, right?
You're saying in the current one? In the current one, right, we have to send the revocation list, right, and update the revocation list, right?
Yeah.
Yeah, it's the same. You just need to send revocation information, not the revocation list. Well, whatever. It's also some information that allows the peer to verify if the user was revoked or not, except the mechanism for that is not just matching the revocation handle in the clear from the list, but rather doing a zero-knowledge proof verification using the values that were communicated within this CRL or CRI.
Well, but now you're validating that it is not revoked, right?
Yes.
Does that mean that you need a full picture of all of the user base, not of all the user base, but some zero-knowledge derived picture of the user base in the MSP at all times to verify users?
No. So I explained the methods that we'll use in a very detail later. So please be a bit patient, and I will cover these questions later. And if we still have one, we'll discuss afterwards.
So, Anil, maybe I missed. So, are you just saying what the endpoint is here? So we have the existing register mechanism. I got that.
Yeah.
In the normal case, to get a eCert, we use enroll.
Yeah.
And there's an API enroll. So you're saying instead of using the enroll API, which we get for the X509 certificates, we use this API to get the Idemix credential?
Yes. Yeah.
Okay.
So it would be a new endpoint, but like in the next slide, I talk about. So we also have a command, right, to enroll. So we would have basically use the same command with a flag, Idemix flag, to basically in a sense in the background, it's calling the new endpoint to get the credential, Idemix credential.
Right, but on the previous one, so do I have to call this API twice? Once to get the nonce and then once with the nonce?
Yes.
Okay.
It is a two-step process.
But it's the same endpoint.
Same endpoint, yeah.
Okay.
So in the next, like I mentioned just now, so we also have an enroll command today to get X509 certificate. So we will enhance that enroll command to get Idemix credential. So it will take a new parameter called --Idemix, which will indicate to the command that the user is requesting a Idemix credential. So if you use this command, it will hide the two-step process. It will get a nonce, and then using the nonce, it will create a credential request, and ultimately get back a credential, and store it on the disk in the MSP folder. So the nonces, nonces and credentials will be stored in the database, in the CA database on the server. Nonce, so it needs to know whether the nonce that user sends back is valid. So it will maintain a store of that, and then it will verify, and it will have an expiration associated with it. Similarly, and then the credentials will also be stored like we stored the certificates today. We will store the revocation handle, the name of the identity who owns this credential bytes, the CA that issued the credential, expiration time for the credential, revocation time, and the reason for revocation. So this is all the information that we store for certificates today. The new stuff is, instead of serial number, we'll be storing revocation handle. Instead of certificate, we'll be storing credential bytes. So everything else is same. And then I think Maria touched upon revocation authority, which will be used in this flow. I think like we talked in the previous slide, where when the CA will talk to the revocation authority to get the revocation handle and the CRI. So just next thing is next slide. We talk about revocation. So in revocation, again, so we'll have a new endpoint to ask to basically request to revoke a Idemix credential. So the new endpoint will basically you can request the CA to revoke all the users' Idemix credentials, or you can request a particular Idemix credential to be revoked. So where it will basically when a revocation request comes in, it will talk to the revocation authority and to revoke the basically so because the revocation CA already knows all the revocation handles that are associated with the user, so it will basically pass that information to the revocation authority to revoke those revocation handles and then send the response back to the user. So as today we have an option. So today, in fact, with X4 certificates, when a user revokes a certificate, we also send the CRL information back to the user. We would do the same thing for Idemix credentials as well. Any questions on that one?
So just to add a little bit, so we might not update the CRL like every time that someone is revoked, but to kind of make things more efficient, we can collect these revocation handles within the epoch, which is configurable, and then update the CRL just at the end of the epoch, and then publish the new version of the CRL, like, for example, like once a day. And that would also kind of make things more efficient. So the revocation component can handle both. So it can handle a list of revocation handles to be revoked at the same time, or just one, and then we'll update the revocation information accordingly. So
yeah,
that's the matter of configuration.
Okay, go to the next slide. So when the user enrolls, we send the Idemix credential as well as the CRI. We return both, but later on, if the user wants to get a new version of the CRI, we'll provide a new endpoint to do that. So this endpoint will basically accept the user's Idemix credential, a token based on user's Idemix credential, which is similar to what we do with the X509 certificate, the same mechanism. So instead of a certificate, we created a pseudonym, which you can think of it as a certificate, in this case a public key, and a signature over the hash of the pseudonym, base64 encoding of the pseudonym, and base64 encoding of the request body. So this is the same mechanism that we use for creating a token based on X509 certificate. So and then
I guess I should have asked this before on the normal one. Why do you need any security on getting this? I mean, in general, why do we need it on getting the CRL either? But why would we actually? This doesn't reveal anything, right? And it should be public information, no?
Yeah, I think I'm not sure why it was made, why it required the authentication, but I mean, maybe to prevent the attacks. Huh?
You added the info. But yeah, I agree. I think so. URL to be public info, just like this could be.
Yeah, there was no reason for that. I think. I mean, if it can be public, we could make it public.
Yeah, I was just saying, so we don't have to. I mean, I guess this is sort of the same, but again, it's just easier if we don't have to.
Okay.
Right, we have the SDK work to do, so. Okay.
Is it a lot of time to compute that stuff?
Sorry?
No, just code, right? I mean, there's always code, but.
No, what I'm saying, if it takes a lot of time to compute that and return it, if somebody keeps calling it without any quick check if they have authority to do that, isn't that kind of a denial of service?
Yeah, that's the one thing that we would be worried about by opening it up, denial of service attack, I guess.
Yeah.
Well, one can also have like more simple authentication here, but like.
Okay.
I think in that case, in this case, Idemix CRI and the CRL is both public. There is no difference. It's just the format is different. But however, the CRL is handled here. The Idemix CRI is also can be handled here.
Okay.
So, move on to next slide. So we talked about revocation. So we'll introduce a new endpoint. This endpoint also takes a token authentication based on Idemix credential. Similarly, we will also enhance the existing revoke command that we have in the Fabric CA client to accept 3 new parameters. So one is Idem -- Idemix, which will revoke all Idemix credentials of a user, and --x419 would revoke all x419 certificates, and then if you don't specify anything, it will revoke all the credentials and all the x419 certificates of a user and revoke the user. And it will also accept a revocation handle that will revoke that particular revocation, so that particular credential. Like we do today, to revoke a certificate, you can pass in a serial number and a AKI. Yeah. So you can you can revoke a particular certificate. So similarly, it will accept a revocation handle to revoke a particular Idemix credential.
Any reason you wouldn't allow the normal token, the ESER token in this case?
So
yeah, that's what I was going to ask. Is there any reason why we can't? I guess I was going to ask the same thing as Keith, right? Is there any reason why, in general, right, we can't use we can't use both if you have one or the other?
There is no. I think I should have put both. I think not just Idemix credential. Yeah, I mean, if the user has either x419 certificate or a credential, they could use both, either to do any of these tasks.
Yeah.
So
okay.
I'll update the document. Yes. Thanks.
In fact, if there is no privacy requirement on calling this endpoint, I guess this is done by administrator or someone who is has to be authenticated. Then there is no reason to have an overhead with Idemix credential here. But we just have it just in case.
The user would need to have a same access control mechanism apply that we use for today for x419 certificates, which is user need to have an HF revoker privilege, as well as we also do an affiliation check. Make sure that the user is the person who is trying to revoke has affiliation that of the user that is trying to revoke.
And also just a slight comment here. So this auth token with Idemix, it says signature over hash. This is not a signature. This is like Idemix signature. So this is a zero knowledge proof that reveals certain attributes, and it corresponds to that also pseudonym. So yeah.
Okay, so Maria, I will pass it on to you to talk about next few slides.
Okay, yes, basically this is already have been discussed. To sign transactions, basically the user needs to get the latest revocation information. So either from the endpoint specified by that Anil described. So either certificate authority has a call to revocation authority component or not. It's just so it depends on the epoch. So revocation authority can just call the CA can only call array once per epoch, for example, to get the fresh CRI, and then it can just keep it and then respond with it to the queries by the peers, users, or whoever wants to access that. So, and based on that CRI, the user is able to sign transaction and create a non-revocation proof. So, and how we do it will be a bit later. So, if you could go further, Anil, the next slide.
So, is there any way that we could? I mean, I know, always setting an epoch. There's a balance between responsiveness and performance. If we could recognize that the error had occurred because of a revocation was stale, then well, I know there's a disadvantage there of perhaps causing a thundering herd of clients going back to the Fabric CA at the same time. But I'm just wondering if that's an option to so that we don't have to get this balance of what the epoch should be set to regarding for responsiveness.
So there are different ways to handle that. So first, the user gets their CRI every beginning of every epoch, like automatically. Then also the amount of the information that needs to be downloaded can be also reduced per user in the whitelist approach, for example, that I'll describe later. And so it can be done once per epoch. It can be done before the transaction signing, or it can be done after the transaction signing would fail. But of course, failing the transaction means like to have to resubmit the transaction from the beginning, and I don't think that's the most optimal version, but it's kind of it's up for discussion. This is not.
I'm just curious and Gary, maybe you could speak to this, what kind of values people might set for epochs, and do you think this is a doable? People are going to set a day for revocation, and then if they get, I would think in certain cases, you kick someone out, you've got to be more responsive than a day.
I mean, yeah. I mean, my guess is they're probably going to generate it when they kick them out.
Yeah.
So, but how is it done with the X509 CRL? Is it propagated every time someone is revoked now, or is it?
What do you mean by well, no, I think there's two things, right? You revoke the certificate. Actually, do we now? I forget. We added this, right? It used to be. Do we actually now generate the CRL when you do the revoke? Do we respond back with the CRL, or we still make you? We separated revoke, and we still make you get the CRL.
Both. You get the CRL back with the revoke, and you can get it, separately as well.
You can get it separately too, yeah. So I mean, you could separate it out. So in the case of if there was somebody doing a bunch of them at one time, you could generate it on demand, but I think you're going to have to generate it. I don't know. I mean, look, let's face the facts. People don't revoke people like all the time anyway, right?
Yeah.
I think we have to have it available after every revocation. I mean, we could try to optimize, right, and say, well, we won't generate it until you demand it.
That's also an option, yes.
So there's a matter of generating as well as updating the revocation information in the channel configurations, right?
Right.
But we don't do that automatically, guys. So that doesn't matter, right? That's you have to separate that out, right? You can't. Yeah, you're right, Anil. But I mean, that's right. That's what the user has to do, right? The user needs to go get this thing before and then they can go update the channel. But it's just you're going to want this probably at the time that you revoke one or more people.
So now is the channel updated after every revocation, or is it propagated later?
But never. We don't propagate it it's a manual process to propagate to the channel.
Or in this case, it can be done exactly as it's done now. You revoke, you get the new CRI, and then you propagate it manually as you would do for a CRL.
So in this case, we don't need to do that, right, Maria? Because I thought that the users we don't support Idemix credentials for peers and order communication. So it's only for the users, end users, right? So
the peers need to have at least to know which version of the CRL is the most recent one. This will show up in the next slides. I will show you.
I guess my
question. So the verifier needs to know under which. So now, whenever peer verifies if the certificate was not revoked or not, it needs to compare the certificate number with if it's on the list or not, right?
Yeah, but
otherwise, how the revocation check is done now? The same is for Idemix, right?
Yes, I understand. But my question was, do we need to update in the channel configuration?
Yes.
Okay.
Yes, that's where you update. Yeah, that's where you update. It's the same. This is the exact same. This is identical, right? Because transactions that flow through the system, right? Other than admin, I mean, there's the rare ones that use the dreaded local MSP, my nemesis. Admin basically, right? And then everything else, right, is based off of the MSPs that are in the channel. Okay. So this is 100% identical to the current flow, right? And we know we can't propagate to the channel because we have no idea what channels this thing relates to, right? So it's up to, it's a separate problem. So we're not adding or we're not making anything better or worse in this case, right? I think the normal flow is someone's going to come in, revoke one or more identities, and get the CRL and then propagate it to the appropriate channels. If we're worried about the compute power on the amount of compute or the time, on it, we could do something where like the Revoke API doesn't return the CRL right away as an option, like in the case where somebody wanted to come and wanted to reject 4 or 5, identities, right, and then do it. But in general, we should have the CRI available at time of revocation.
Okay. That's why it now kind of accepts either a list of revocation handles to revoke, and it can be one or it can be multiple.
So yes, you already took care of that. Got it. Yeah, that makes sense. So right, you can do it all in one call. Got it. Yep.
Okay. Next slide, Maria.
Yeah, so now it comes the revocation details part. Please bear with me here. So there are 2 approaches, and I will explain details of that, like high-level intuition. So first approach is a very, very efficient one. I'll compare the efficiency in a table later of both approaches, but it only scales well where we have like thousands or tens of thousands of users. So because it's a whitelist approach. And the second approach is very, very scalable. It's good for millions of users, but it's less efficient for the proof. So that's why we present both, and we think that for a system with less users, it's better to use this one, and for systems with a large amount of users, it's better to use the second one, and I will explain now why. So. And we implement both, and they will be kind of transparent, so they can be configured by just a config file. So Basically, the first is a very simple approach. It's a whitelist approach. The revocation authority generates a long-term signing and verification key. And the revocation handle is a special attribute inside a credential, so it's signed in a credential. And the revocation information has a version or epoch, doesn't matter. The epoch key, which is a verification key of the authority that is used to sign the revocation handles. And also a signature of that verification key. I explain later why we need to have it. That allows us to actually only distribute the long-term key to all the peers, and then they don't need to fetch all the signatures from the CRL. The CRL would contain the signatures on all the valid revocation handles. That's why I'm saying that this is good until a certain point where we have thousands of users. Because these signatures are very efficient, and the proof of possession of the signature is also very efficient. So if you go to the next slide, Anil. So the user, to basically generate a non-revocation proof, it generates a zero-knowledge proof without revealing the revocation handle and the particular signature. So it fetches the signatures. It can also fetch just the corresponding signatures to that user. And then it proves in zero knowledge that it has a credential that signs this revocation handle, and there is a signature from a revocation authority from the particular epoch or version of the CRL, that the latest one, that signs also this revocation handle. And this zero knowledge proof is very efficient, and we don't reveal neither revocation handle nor this particular signature that also identifies which revocation handle it is. So if you go to the next slide. And then the user can also just send this S, which is a signature on this epoch verification key, so that the peer doesn't even need to fetch that epoch key. So it only needs to know which version of the CRL is the latest one. So, or it also can fetch that epoch verification key. So basically, the amount of information that the peer stores, the verification peer stores, is just like constant, and it's not linear to the. It doesn't need to store all these signatures. So basically, the corresponding signature is only needed by the user to verify. The peer only stores the public key of the revocation authority, and the verification of the non-revocation verification is just verifying this zero knowledge proof. Because we have to provide the privacy and hide the revocation handle, we have to use more advanced functionalities, and that's one that is very, very efficient compared to all the others. But as I said, it only goes well for a small amount of users, because the computation power of the revocation authority is linear to the number of valid users. Also, the valid revocation handles can be pre-signed at the revocation setup. So the revocation authority kind of picks like 1,000 revocation handles, signs them, and then whenever the user is getting a credential, it provides a non-used revocation handle to the CA, and then automatically the user is on the whitelist. So this is we don't need to update it every time we add the user in the system. So on the second approach, if we go to the next slide, is also a signature-based approach. Except now we don't sign every valid revocation handle, but we sign kind of the sets, like the the first and the last one in the we sign ranges of valid revocation handles. So the amount of signatures is now proportional to the number of revoked users, because if you look at all revocation handles as like a list, and then you revoke here and there, you only need to sign the ranges that are valid. So In that case, the CRL and the computational power, the amount of signatures that the array needs to compute, is only linear in the number of revoked users. But of course, now the proof is a bit more complicated because you don't only prove that there is a signature on this array RH1Y1 and RHYIV. This is like a range borders of the range, but also you need to prove that your revocation handle is in this valid range that was signed. And this is a range proof, and this is what adds the computation complexity. So, and if you go to the next slide, Anil, there is this table that compares both approaches. So, is the next slide displayed? Hello? Yes. Sorry, I have probably network delay here. Basically, now this is a comparison of both approaches. So both are signature-based, both preserve privacy, both don't require special secrets that users need to keep, like for accumulator-based approaches. But now this range proof that is required by the second approach basically makes parameters of the array a bit bigger than just a very small number. The CRL size in the first approach, of course, it's a number of all valid users, and in this second case, it's the number of only revoked users. So this is much smaller, and the computation power is much smaller for the array. The CRL size is actually the verifier needs to have is very small because it's still signature-based approach, so you only need a public key to verify the proof. As I said, computation is different here in valid versus revoked users. Computation for the user and verifier are the same, so basically it's very efficient for the first approach and more complicated for the second approach. And that's why for different amounts of users, we really recommend two different ones. Because if it's a really small amount of users, the second one will be just the unnecessary overhead. And that is not needed. So are there any questions? I know we're kind of running out of time, but still.
So basically, if a peer is not up to date, it will refuse to endorse an Idemix user if the RH has an epoch which it did not get the CRL yet, right?
So it depends. If the peer only has knows that epoch is the latest epoch, that's enough. It's enough just to have the global long-term public key of the revocation handle. Because you also sign, I think I didn't say that, but you also sign like epoch number together with the verification key there. So it
but the peer doesn't have the latest. The peer can't go to some CA and get the latest, right? It updates its CRL via the blockchain.
Yeah, but it needs to update. So the CRL in this case is just the version of the epoch. So it's just the epoch. Yeah, but indeed it will reject. I mean, the proof will still verify because the proof is basically the proof is done if the user also sends a signature of the epoch key. Then the proof is kind of independent, but then the verifier, the peer, would see that this is an old public key that is was used in the previous epoch or in the previous version of the CRL, and then it can reject that because it's outdated proof.
Okay.
Yes, and I wanted to briefly touch on a few things, like the expiration date for certificates. So this range proofs that we will implement, that we are implementing for revocation, can be also used to prove that the expiration date from the certificate is not, so the certificate is not expired, so the expiration date is more than now. But this is additional range proof, and this is also kind of adds the computational complexity to the proof and verification. So now the expiration can be actually done through revocation, because while revoking the revoked users, the CA can also trigger revocation of the expired certificate as well. So that also can be done in one batch at the end of the epoch. And then it would save the user extra range proof in this case. Because if the user would just reveal the expiration date from Idemix certificate, that can make him linkable. Depends on how exact the expiration date is, but if I reveal twice that my expiration date is like right now, then probably it's me again. So for now, we support expiration through revocation, and then in the next version, we add this extra
Hey, Maria,
range.
we're going to have to wrap this up. We get several people got a hard stop.
Okay.
If people have follow-on questions, maybe we could use either Fabric CA or Fabric Crypto channels and keep any discussion going there if you have more questions.
Do we need to have a new meeting for this to discuss this, Maria, or?
No, I think it's just I wanted to say that we don't support a lot of attributes right now. It will come later. And then the BCSP refactoring, we can also discuss on the channel if it's good to do that. There is an issue open, and one, like maybe people can vote for that one. But we think it's good to refactor the mix to basically comply to BCSP interfaces. That's it, actually, that we wanted to discuss. So.
Okay, thank you very much. Hopefully Mark will be back in next week, and I'll post the recordings in the wiki. I need Mark to do that with his YouTube ID. So hope you'll see all of them start to collect out there starting early next week. All right, guys. Thanks.
Yeah, bye.
Thank you.
Thanks.